Hello, everyone. Hello. How are you? Good to see you. Actually, my name is Gáspár, as you have heard, and mostly people know me because of my enthusiasm or maybe addiction to behavior-driven development, and I'm also the creator of the open source tool called SpecFlow, which we actually rebooted this year. So if you want to go to SpecFlow now, then you should go to Rack and Roll. That's the new name. But actually, this presentation is not about that. And the story really goes back in time when I was working with a team. And when I was working with a team, actually, we had a couple of stop words, words that you were not allowed to say. Or if you said that, then you had to put some money into a jar. And actually, coverage was one of them. Because we somehow felt that if someone says coverage, then it's pretty sure that what he thinks about when he says that is probably different than how we understand it or how the other parties understand it. So it's just causing confusion. So we just basically denied using that word. And actually, I also had a conference talk where I was even saying that, that full coverage is an illusion, and which I probably still true. But so with that background, it might be a little bit surprising why I have chosen this topic for today. But actually, I thought that this topic was somehow puzzling me, and I thought that, okay, let's come back to that, and let's see what I can get out of this for today. Okay, so let's make a quick check. So how many of you have heard about requirement coverage? Almost everyone, very good. So how many of you somehow feel that you know what it is? Okay, almost good, almost everyone. How many of you are using it in your project? Just a few. And from these people, how many of you feel that this is kind of usable or useful? A little bit less. Okay, so that's great. Yeah, by the way, one more question. So how many of you know about Mythbusters? Okay, very good, almost everyone. So I really like this. This is basically a science entertainment program which was running on Discovery Channel. And basically the goal of this TV show was to validate the truthness of different statements, rumors, stories, whatever. So I thought that if I want to dig into the details of requirement coverage, maybe we should try to validate that. So that means that, that we would need to know whether requirement coverage is useful. That should be the topic for today, or that's what I invite you to figure out. So many of you know the Mythbusters, so you probably know that there are two main characteristics of this TV show. One is that there are a lot of explosions in there, okay? And the other is that the characters are having some funny beards. So that's, I think these are the two main things. So let's figure out which one is more exciting for you, because I mean, I need to plan the presentation based on that. But be careful, I have a red button, so just whatever. So there will be a couple of places in the presentation where I would like you to choose between two things. So I developed a kind of voting mechanism. It's very simple. You have to use your hand. It doesn't matter left hand or right hand, either works. And if you think that explosions are more exciting, then you should hold your hand like that. Be careful with the person sitting next to you. And if you think that the funny beards, then just go this way, okay? And I have to be careful with the microphone. Okay, so let's try this. So explosions or funny beards? Or, very good. So you are more for the explosions. I will not press that. Actually, I was also presenting this idea to my wife, and her answer was no and no. And you know, when you hear that kind of no, then you know that this is really a no. So I actually had to change my plan a little bit. But by the way, this is what you have missed. So still, I feel like a kind of a do-it-yourself person, so I really like to take things apart and try to put them together. So I thought that at least this one we can keep for the presentation. So that's probably going to be the kind of the theme for today. So we are trying to take the requirement coverage apart and then try to put it together. So the first one, we will start with some sort of definition, or try to dig into the definition of the things. We will also see some kind of potential problems or problems that you might see if you are using requirement coverage. And then I will try to show you some approaches how you could get more useful things out of that. There will be 3 of them. And if I will have enough time at the end, then I prepared with 2 goodies, some things that are really keeping me exciting, and they are just ideas and absolutely open. So that's going to be our topics for today. So let's jump into that. So first, let's start with the definition. And actually, the requirement coverage doesn't really have a very established canonical definition. So I have taken one from Cristiano Catano, who is a good expert in the topic. And he was basically saying that requirement coverage is a measure in software testing, indicating how well the testing process aligns with the specified software requirements, and it ensures functional correctness and boosts confidence in software's overall reliability and performance. I think there are pretty good things in there, but for me, at least for today, the most important things are going to be that this is a measure, okay? I'm really interested that this is related to the functional correctness, so that is going to be our main goal for today. And I think it's also important that it's somehow related to our confidence about this kind of quality criteria. So that's basically how the definition looks like. And let's jump into that. And as Cristiano said, that requirement coverage is some sort of measure. Metric is similar thing. Basically, metric is a measure in a context. So if you are measuring requirement coverage for a project, for a function, for a component, or whatever else, then it becomes a metric. And let's see how that works. And I know that all the keynote principles says that don't ever show a mathematical formula after 4 p.m. So I know that I'm really risking the thing here, but I thought that it will look much more scientific on one hand, and on the other hand, it's really simple. So basically what this formula says, that just count how many requirements are covered, and divide it by how many requirements you have, and just make it a percentage, and that's going to be your requirement coverage. So that's the formula. Maybe 2 things make sense to highlight here. That what do we mean on covered? And that might be interesting, but mostly people say that it's covered because if there is at least one test for that requirement which is covering it, and of course, if you are in the implementation phase, that particular test should also pass. Otherwise, it wouldn't really make sense. And the other thing is that what is a requirement? And basically, at this point, requirement can be anything. Okay, so it doesn't matter, actually. It can be any kind of unit of specification, unit of expectation. So that's basically how the formula looks like. So that's one form how people usually see requirement coverage as a metric. And there is another form that is typically shown, which is called the requirement traceability matrix, which is usually shown in the form of an Excel sheet, even though that obviously in a real project probably it's not really fitting to a real Excel sheet. But I think this example makes it clear. So there are different forms of this Excel sheet, but maybe that's the easiest to explain. So you have in the rows, you have the different requirements. On the columns, you have the different tests. And if one test is covering or dealing with that particular requirement, then there is something on that cell. Either you can just have a marker that this is going to be covering it once we will run it, or if you are in the execution phase, you can even record whether it was passing or failing, and that's basically what gives us this kind of the matrix. And as you can see, if you would try to make some sort of grouping or accumulation of the different rows, then basically we could count how many requirements are where there is at least one tick mark on the row, and basically we would get back to the formula. So basically these 2 things are kind of interchangeable from this perspective. Okay, that's great. So if requirement coverage is a metric, then maybe we could see whether it's a good metric. And of course, first we would need to define what a good metric is. But fortunately, we don't have to do that. There are plenty of articles, plenty of science papers which are just listing what kind of characteristics a metric should have in order to say that this is a good metric. I was just choosing a few of them randomly. I will not go through them anyway, all of them, but if you want, if you Google for that, you will find a couple of others as well. I think these are, most of them are self-explanatory, so that I don't need to go into the details. But actually, if you would go through these characteristics one by one, then you would see that requirement coverage is not necessarily fulfilling all of them, or not necessarily performing very well with these. And I will pick two of them and showing basically two kinds of problems that you might see if you are working with requirement coverage. The first problem is related to the strategic aspect of that. Strategic means here is that whenever you see the value of the metric, so the concrete percentage, then it should, by reading that and seeing that changing, that should help you to go towards some meaningful ultimate goal, so some strategic goal. Okay, so that's the strategic characteristic is. Let's look at that a little bit more in detail. So requirement coverage is calculated as a percentage, right? So we have a scale from 0% to 100%, okay? And let's just imagine this situation, and let's just pick something in the middle, like the 50%. So just imagine an application where half of the requirements have been tested, okay? The other half, not tested. I don't know what word comes to your mind when you hear that, but for me, I think I labeled it with a bad application. That's not where we want to be, right? Of course, we can go more to the positive side, so go to the 100%. That means that every requirement has at least one single test. I don't know how you feel about that, but for me, this is kind of the bare minimum. So I would say that without that, don't want to go further, right? And unfortunately, we can go to the lower side. I was really thinking a lot what to write on the 0% to stay in the code of conduct of this conference. Escape from there. That's what I have finally chosen. And actually, we also feel that the scale somehow doesn't stop here. So we know that if we are doing more tests and caring more about the quality, then there are things more on the right-hand side, right? So if you do a little bit more testing, then probably at some point we are getting to the stage of the OK applications. And if you go further, then we maybe get into the usable. And probably there are some superb, or we can even go further. But unfortunately, this requirement coverage is just telling us 100%. So you see? So basically, this metric is very good in telling us how bad we are, but doesn't really help us with the goodness. Okay, so you see how this strategy quality is somehow broken. Okay, the other is the comparativeness. So by comparing the numbers, you can compare the things. Let's make two tests for that. First of all, let's imagine that I have a feature 1, which has 5 requirements. I really spent a lot of time how to visualize the requirements. The barrels are the requirements. 3 of them are covered, okay? And we keep working on this feature 1, so there is a later version of feature 1 where now 4 of the 5 is actually covered, okay? Let's forget about the formula right now, just consider our feelings, right? So what do we feel? So which one is more covered, the F1 or the later version of F1? Let's make a voting. Yeah, I think we all feel that that one is definitely having more coverage. But unfortunately, if you calculate the formula, then it's not unfortunate. This is still working. So if you calculate the formula, then metric is basically saying the same. So this is all good. The first test is passing. But we can have another test. And with the other test, we have 2 other features, F2, which has different sizes of barrels. The 3 smaller ones are covered, and F3, where 3 bigger ones are actually covered and 3 smaller ones are not. So how do we feel? Which one is more covered? Not thinking about formula, but just our feelings. Yeah, we also feel that this one has more coverage, right? I mean, these big barrels are all green. However, if you calculate the formula, it just says 50 for both of them, so actually it's somehow failing, right? So that's not good. But I think this is not a big deal, right? We all feel what the problem is. The problem is that we were treating all these requirements as equal. However, it's obvious that these are not equal, right? So how can we make 2 requirements equal to each other, right? We see that it differs. There are some smaller ones and some bigger ones, right? So there is something that we would need to integrate into that to make more meaningful result out of that. I don't know what's your experience, but for me, I always get to the point that it's always the requirements that have the problem, right? So, yeah, anyway. And to be able to progress, and as I said, so far we were basically taking this apart. Let's try to put it together. I will show you three approaches. These are not solutions, more like approaches that you can consider. Two of them would be related to this defining of the size of the requirements, and the third one will be related to the nature, the structure, the granularity of the requirement. Okay, let's first focus on this size. It was easy to say that there is a smaller barrel and a bigger one, but of course with requirements that's not so easy. What does small mean? What does big mean? And how you quantify that? That's absolutely uneasy. And I think there is no real very fixed solution for that. So what I was calling, instead of the size, I tried to call this thing complexity, okay? Because the size is maybe not that perfect. So we feel that there are less complex requirements, and we feel that there are more complex requirements. So that's how you should feel. But of course, we would need to quantify that somehow. So we would need to calculate what is the complexity value for a particular requirement. And unfortunately, this is not easy. But because we don't have too much time, and anyway, it's after 4 p.m., let's just take a stupid definition for that. The stupid definition for that, just for today, okay, just bear with me, that we are defining the complexity by how many tests do we need for that. Okay, and you know this is a kind of a recursive because we want to define how many tests do we need by the complexity. But anyway, just leave with that for a second. But we feel that if this would be if this wouldn't be recursive, that this would be a good definition. And let's see what we can do with that. Oh, sorry. Don't even look at that. I really don't want to ruin your evening. But you could make a better, if you put this information to a mathematician, then they would put out this formula and then you can trust them. And if you would do the same test with that, actually what would come out, let's say that the small barrels have a complexity equals 1, the bigger ones have 4, then it would come out that that one has a coverage of 20%, that one has a coverage of 80%, so everything is all good. So it looks like that if we would have a complexity metric or measure, then this would save our life with the requirement coverage, or at least we could modify the formula to be able to handle that. Okay, but how can we do that? And as I said, there are two approaches that I will drop in. And the first one, I don't know how much it is surprising, is model-based testing. And I know that some people, there are some model-based testing fans. I don't ask you to raise your hand because maybe you want to stay in the incognito state. But so model-based testing would be one idea. Model-based testing, if you don't know, very simplified explanation is basically in model-based testing we are making models or partial models of our system, and maybe just for a feature, maybe just for a requirement, and basically we use that to be able to guide our testing, at least for model-based testing. And of course, there are models that look like that. There might be models that look like that one. So. And I think even if I don't show anything, if you just look at these two pictures, let's make a voting. Which one you feel is more complex? Which one has the higher complexity? Yeah, we all feel that this is the right one has more higher complexity. And actually, because model-based testing has quite some scientific background, even there are some mathematical formulas that are calculating some sort of complexity metrics. For example, the most commonly used is the cyclomatic complexity. Not go into that. Apply that, and it just gives you a number. In that case, it would give me that that one is a 9, and that one is a 1. Sorry, and that one is a 1, and basically that we could use that to be able to get the complexity of the different requirements. That's all good, and so far all the model-based testing fans were happy. But actually, the unhappy part of that is that so model-based testing is still not a full universal applicable solution. Obviously. You can use this method even without any model-based testing tool. Just go to your whiteboard, sketch up your requirement. Maybe it's anyway helping you to understand the requirements. So this has a lot of benefit. But maybe not all the requirements can be drawn like that, or not all the requirements make sense, and the maintainability. And there are some other challenges. So therefore, if you can do models for a particular requirements, that's great. but sometimes you cannot or not practical to do that. And this is where my second approach would come, maybe even more surprising, but the second approach is related to specification by example. So actually, specification by example is a collaborative approach to defining requirements based on capturing and illustrating requirements using realistic examples. So that would be it. And again, specification by example is a big topic. I have 2 slides to explain that to you, so it will be a little bit oversimplified, but that's the story. And by the way, specification by example is the core concept that is used by behavior-driven development, acceptance-driven development, keyword-driven development if you do it with robot. So this is a core concept of that. And the story of specification by example is really related to the requirement knowledge handover. What I mean by that is that there is the product owner of the business who has a great idea, a new feature, a new whatever requirement, and they have a team who would need to write a very nice and beautiful application out of that. Okay? And unfortunately, in a classic setup, this knowledge handover, how the product owner or the business is telling the team what to do, is a strictly one-directional flow. And it's typically done in a way that these product owners, business people, just writing down the requirements into some specification document, business requirement document, whatever, and handing them over. Maybe there is a small discussion on that, but the document is the thing. And because of that, so because it's really written down and handed over to the team, what comes out of that, that these documents, these descriptions are pretty abstract. That's one of the problems. But the other problem, which is even more painful, is that whenever the business was writing down the requirements, actually, they have some background knowledge. Okay, so they have some assumptions, they have some domain background, whatever. And when they wrote down those documents, then maybe they detailed some aspects of that were pretty new to them. And maybe they just not really focused on some aspects that what they were thinking that this is anyway trivial or common sense. Okay? And the team is also having some background knowledge, but maybe these 2 background knowledges are not necessarily matching. Okay, so maybe what the business was detailing very much was anyway unnecessary for the team, and maybe what the business was simply skipping by a single sentence would needed more discussions for the team. Okay, so that's a common problem. And what comes out of that is that yes, there are the handover will be incomplete, so there will be details that the team would be needing, but we don't have. And of course, there is a whole bunch of misunderstandings can happen during that process. So this is without specification by example. Specification by example, trying to turn this in a way that this one-directional communication should be converted into a collaborative, multi-directional, or at least bi-directional communication by, as the definition said, trying to discuss these requirements by collecting concrete, realistic examples. And what I mean on an example that we are sitting down and imagining that how the user is going to use that particular feature, that he will click on that button, he will enter this data, he will do that, and this is what he will see at the end. So that kind of detailness you should imagine with that. That's specification by example. And another additional extra benefit if you do that, and I think in a testing conference I don't really need to highlight that, if you have such an example, so you know what the user should click and what the outcome should be, then actually this can be very easily converted to tests. I wrote here automated tests, but even manual tests. Okay, so it's very easy to convert these examples as tests because they are working really similar to examples. They are going step by step what they should be done and what the outcome should be. Okay, so this is how a very short summary of specification by example, and maybe this that we are discussing about examples sounds a little bit too esoteric or hard, but it is a simple process. It's a very simple process. Sometimes it's really just starting with a very simple question like, hey, could you please give me an example to that? And typically business and product owners are happy to respond that, and they will give you some examples. But if you want to dig more deeper to that, there are some meeting facilitation techniques. If you Google for example mapping or feature mapping, those will give you further information on that. I'm not going to these further. So This is specification by example, and probably you are still surprised that, okay, that's great, but how does it come to complexity, right? That should be your question. So what we have seen so far, that we are collecting these examples, right? We also seen that these examples can be converted or can become tests, right? And you remember, and by the way, these examples are also connected to a requirement, because we were discussing that requirements where we were coming up with these examples, and they are very focused. So one example is really belonging to a single requirement from this perspective. And so they can be converted to tests. And you remember what our stupid definition of complexity was, that how many tests do you need for that? And if the examples can be converted to tests, then the number of examples are actually in a good correlation of how many tests do we need. So basically, it's a good correlation of what complexity could be. So it's a very important characteristic that the examples are available pretty early in the process. No code line has been written, no test definition has been written, right? But we already have a feeling about complexity, which in simple case, it could be just the number of examples in a very simple case. Okay, you see how this is actually approaching? Model-based testing is a very good structured approach to that. Specification by example is a more pragmatic approach, and the two is working very nicely together. Okay, so that's about the complexity. The other thing, and the third approach, as I said, would be somehow related to that. Okay, but what is a requirement, and what kind of granularity, what kind of structure do we want to have for the requirements, or simply saying, okay, what should be that requirement really in practice? And and for that, let's just take the concept that we have seen with the specification by example, that we have collected examples. If you do spec by example with a team, then usually these examples and this requirement knowledge handover is happening on the work item that you are working, which is in most of the cases, at least in Agile team, is a user story, right? So teams are discussing user stories, right? That's the common flow. Or maybe if you don't call it user story, but it's the same. So teams are discussing user stories. So basically, one practical choice for calculating the requirement coverage would be a user story. So we anyway know how many examples we have for a user story, so we know the complexity of that, and so we basically have a good guess how many tests that user story would need at the end, so we can measure the requirement coverage as we implement the user stories during the sprint, and that will give us a very good progress of work. So that would be great. However, in practice, what turns out that finding the examples directly for the user story is not that practical. If you would ever try that, then you would say that, okay, let's find the first example, and then you would ask the question, okay, but how many other do we need? So when to stop? When we can say that we have collected enough examples, that would be pretty hard. Or did we really cover, again, the coverage word, did we really considered, yeah, that's good. Considered all the aspects of that, and did we created an example for that? So in practice, and this is because user story is basically just a high-level goal. So this is a high-level business value. This is what we want to achieve. But normally, user story doesn't have a scope or doesn't have a very fixed scope. That's why negotiation and many other things can come in. Fortunately, there is a way to fix the scope of a user story. In Agile requirement management, these are typically called the acceptance criteria. Many teams are interpreting acceptance criteria in a different way, but at least in a classic way, acceptance criteria are those rules. In BDD, we are typically calling these things rules. Those rules, those general expectations that has to be fulfilled by the implementation. As you see, this is basically setting the scope. If all these expectations are met, then our user story is ready to be done, or ready to be accepted. So this is where the acceptance criteria term comes from. And so when we collect examples in a specification by example process, so we typically not collect the examples directly for the user story, but it's much easier, it's much more straightforward to just go acceptance criteria by acceptance criteria, and just focus on that particular acceptance criteria and collect the examples for that. Okay? It's obviously it doesn't fully solve this completeness question, but it's much better. Much better to see. So if we have collected at least a few examples for each of the acceptance criteria, or each of the rules, then it's more likely that we have really completed our task, and we don't need to collect further examples like that. So if you see that. If we see that the examples could be collected, it's much practical to collect those for this acceptance criteria, you can see that actually the acceptance criteria would be a better target for requirement coverage, because anyway we know the complexity of the acceptance criteria by just counting the examples, and upwards it's easy to aggregate. So if you know the coverage of the acceptance criteria, we can easily calculate the coverage of the user story as well. And there is even an additional benefit of that, because user stories are kind of disposable. So that whenever you finished the user story, it's done, it's accepted, then it doesn't really matter whether it was done with 3 user stories or we were lucky and we were able to achieve it in 1. So that's not a stable thing in long term. What is stable in long term is the features that we have in the application, right? So that's every acceptance criteria, every user story is an increment. It's incrementing or just extending our feature set and making our application smarter from that perspective. And so user stories are not stable, so they are in a timely manner, they are not important anymore. However, features are important, and actually the acceptance criteria or the rules are making sense also for the features. So basically those can be, once the user story is finished, basically those rules together with their examples are becoming basically your feature set. So if you did calculate the requirement coverage for these acceptance criteria, then it's also useful in a later time, because you can aggregate it up to the feature and you can calculate maybe requirement coverage also for a feature or something like that. So it's really a kind of a practical approach. So, I mean, to answer that in a simple way, what is a barrel here? Of course, you can still choose anything. So this is just a guidance, but choosing the acceptance criteria or the rule could be a good solution for that, and I think that makes sense from many perspectives. Okay, so so far, we were just going down, taking it apart. Right now, we were just trying to put it together. We have analyzed the problems, and we have seen how those problems could be addressed. And I was showing you this with these 3 approaches. These are not solutions, as you have seen. So I mentioned that I also want to share some goodies to that. So some things that are keeping me excited, and I think maybe they are not really ready to run yet, but hopefully they will also give you some interesting ideas what kind of areas you can further explore. So 2 of them. The first of them, I don't know whether it's surprising, is related to the single source of truth. The single source of truth is a quite widely used concept in software development, but I never really heard that in testing. But how many of you know about what this concept is about? Half of you, or a little bit less. Okay, that's fine. So basically, in software development, a single source of truth as a concept basically means that we would like to have an artifact which is containing all the information that all the other information can be derived from. Typically, in software development, what we would like to see is that all the information is in the source code, and if we need any kind of other artifacts from that, then it could be generated out of the source code. If you know the infrastructure as a code, that's basically a typical example of a single source of truth, because you are coded down those steps that are required to release a product or whatever, and those scripts or those actions that are needed to release a product can be generated from that. So that's single source of truth. If you would think what we have seen so far, what kind of artifacts we have seen, then basically there are 3. Simplifying a little bit. So we have the requirements, whatever it is. We have the tests, and we have this mapping between them. Okay? And if you would look at how do we store, where the information about requirements, test, and the mapping comes from, then you would see that, of course, it depends team by team, but maybe the requirements are stored in some ALM system, like in Jira or Azure DevOps, right? The tests are in a test system. Maybe there is a test tool, or maybe just code it down and it's in a Git repository. And the mapping, yeah, maybe it's an Excel sheet. That's so whatever. So definitely no single source of truth for that, which is not necessarily bad, but it just calls out to you that maybe you could do that better. And I have a client, and with that client, we started to make a prototyping. It's really in a prototyping phase. But what they wanted to have is that they really wanted to achieve some sort of single source of truth for all of these things. And their concept was that why don't we try to use the test or the test descriptions as a single source of truth? How it looked like in that particular at that particular client. I mean, we are doing BDD there, so our test descriptions are basically feature files where you have scenarios. Those are what are representing the test. But in the feature files, you can put other content as well. Particularly in Gherkin feature files, you can have such a rule tags or rule elements, which are describing maybe an acceptance criteria here, and even the feature file can also represent something. So with this prototype, what we are trying to do that they are not only writing down the scenarios, so the tests, but they are also writing down those rules, those requirements, what these tests are related to, okay? And they are putting it into some buckets, some feature files, and they are also describing what this feature is about. And what we do with that, so once this is done, we are performing some sort of ongoing synchronization process, and from this single source, actually we can generate everything. So we can generate and update the feature and the test work items in Azure DevOps. We can generate the linkage between them and basically everything. And whenever the requirement is changing, so somebody is changing that feature file and updating, let's say, the description of this requirement one. We just need to rerun this synchronization and everything is updated. So you can still use your tools just like before. So if you are opening your Jira or Azure DevOps in our case, you still see your requirements, you still see your test. All the reporting of whatever the ALM is supporting you is still given. However, basically everything is coming from a single source. Which is pretty good because basically you can very easily get any kind of coverage reports out of that basically for free. So you don't need to work extra, and you don't need to synchronize the different sources of information. I pretty find it fascinating, and for me it's even the extra bonus in that is that whenever we found the single source of truth, it was actually the test description. So I think it's in a testing conference. This should be a very good news, right? So that the thing that we are doing is actually just promoted, right? That's what we are doing here. I think this is pretty interesting, and as I said, it's in a prototyping phase, but I have good hopes. The other goodie is related to requirement traceability. Basically, requirement traceability is that for any artifact or for some artifacts, you can trace it back which requirement it was belonging to, right? That's what we did with the test. And Catherine Beaton was saying about requirement traceability that it ensures completeness of requirements, facilitates change management, helps with testing and validation, improves communication and collaboration, and enhances project management. So basically, it's a super gold, right? So that I mean, it helps in everything. So working on that and working further on that is I think another interesting area that makes sense to elaborate. One thing that we have seen so far, so we were basically to be able to make the requirement coverage, basically we already have a connection between the requirements and the tests. Okay, so that we have the requirement coverage, requirement traceability for the tests. Okay, but we don't have to stop here. So actually, if these tests are automated tests, the current test execution tools are actually able to measure what is happening during the execution of the test. Concretely, they can also measure which code lines have been exercised to be able to run the test. Okay? So that is called the code coverage, basically. So basically, at the end, you will know for every single line of code which test was using that or which test was executing that. So basically, with this ongoing measure, basically we have an additional linkage between the test and the code. Okay? So far, so good. So, and actually, this is transformative, so that, that basically we have a linkage between the requirement to the test, from the test to the code. This means that we have actually a linkage between the requirement and the code, which is very interesting. What you see, it's a pretty small font, but you will see it's just basically a looping animation. It's from my own development environment. It's not a mock-up. It's actually real. What you see there is that you see my source code. You see even some annotations to that which are telling me constantly how many tests are actually covering or how many tests are actually executing that particular line. And let's say that I was looking at the code and I was a little bit unsure that, okay, why is this condition here? This looks a little bit strange, right? A valid question would be that, okay, why did we have that code lines there? And basically what I was doing there, I was jumping to the related executed tests, and the tests were basically connected to the requirements. So basically from that, with 2 clicks actually, or 1 click, I was able to answer the question that which requirement this particular piece of code is actually connected to. Okay? So this is a topic which is sometimes called some sort of coverage heat map. Maybe the heat map is not really visible here in my Visual Studio because I have just some bubbles on the left-hand side, but I mean the visualization could be probably improved. But basically, what I see from that, I see the requirements of my code right in my development environment. Okay, that's very useful, and actually, you don't have to stop here. Did I say that already? Yes. So not only the code. Actually, if you are using UI automation, then actually by running those tests, you would also know which button has been clicked, right? So actually, you could make a heat map of the UI as well. Just imagine that you are an exploratory tester, and whenever you see the application, there is an additional annotation for each button that this particular button is related to these three requirements, or this button has no requirements attached at all, right? That would be an interesting help for you to do your exploratory testing, and maybe there are a couple of other good usage for that. Okay, and we have all the information for that. We just need to do the plumbing to be able to make that visible. Okay, or another idea that I mean nowadays every application has some sort of API, right? And we are, especially if it's a public API or semi-public, so that within the company some other teams are using your API, obviously you are just generating some sort of document about the syntax of the API endpoint, so what kind of JSON you should send in and what are the query parameters, which is great. But actually, because of the test executions, we know which requirement was actually exercising that particular API. In that documentation, we could also generate a list of links that, and by the way, this and this and these requirements are defining the behavior of the API. Okay, so basically with that you could not only have a static syntax documentation for your API, but also giving some hints for your users about the behavior of that API. Okay, that could be also very useful. And you don't have to stop here. So actually, nowadays observability, right? So that we are able to measure what code parts our users are actually using whenever they're doing their daily tasks, right? And if we know what which code the users are running, and we know that which code the tests are running with a little bit of magical matching, actually we could also match that, and we could even make a kind of requirement linkage, so we would be able to know which requirements our users are exercising more or which requirements are less exercised, and so on. So I think there is a couple of interesting potential here. The requirements of code is something which is working already right now. The others, I haven't seen yet a working solution for that, but you see that we have all the information for that, and I would be very happy if this would trigger any button for you, and maybe for next year you can present how this would be working out. Okay. So that were the two goodies. So we have taken it apart. We were trying to put it together. Hopefully still works. So let's do the polishing, finishing up the surface. So basically what we have seen that we were talking about requirement coverage. We have seen that this is mostly seen as a metric. We have seen the formula and the matrix as a kind of representation of that. We have seen some problems, particularly the problem with the strategic nature of the requirement coverage, and also that the comparativeness was not necessarily working as we wanted. We have seen 3 approaches to improve this situation. We have seen the model-based testing, even in a simplified scale, so just writing up a model onto a whiteboard. We have seen specification by example as another pragmatic approach to that. And we have seen that focusing more on this acceptance criteria level of our requirement breakdown would be also very useful here. And we have seen the 2 goodies, tests as a source of truth and the coverage heat map as some sort of ideas. So that's basically what we have seen today. I don't know whether is this requirement coverage, I don't know. For me, basically requirement coverage is more, I see that more like a process. A little bit of a process that you have seen here. So we were just trying to dig into that, analyze what we want to get out of that, trying to find some approaches to be able to address that. And so basically it's a process that is trying to guide us or guides us towards confidence in functional quality, which is, in my opinion, is exactly the same what working software was meant in the Agile Manifesto. So that's my view on that. Basically, we can go back to the Mythbusters question, so that whether we see that, whether is it a myth or an ultimate goal. Let's make a final voting. So how do you feel right now? So is it a myth or an ultimate goal? Okay, very good, very good. I mean, we have absolutely a mixed answer, which is what I expected. It's your answer, it's your approach, but I hope that with that you got some inputs to work on that, and especially if you feel that it's an ultimate goal, you have some things to do. Thank you very much.
Brilliant job, Gáspár. Thank you so much. Do you have enough energy for a few questions?
Absolutely.
Amazing. Wonderful. Let's see the questions. First one, what tools would you recommend to ensure that requirement coverage is accurately tracked in the team?
So on the tooling, I don't have any fixed recommendations. So I think every company is choosing their tool set because of some company politics and other things. I don't have any preference or something that I would recommend you. There are many tools that can calculate coverage for you with better or not that good reporting capabilities. Try whether it fits to your needs, and try whether actually, so if you Google for requirement coverage, then you will see a lot of tool-opinionated definition pages or articles. Don't always validate them whether they are really fitting to your needs and they are really strategic for you. So having a requirement coverage with a great tool which costs a lot, probably it's a great achievement, but if you are not, it doesn't help you to be better with your strategy goals, then maybe it's not that useful. So unfortunately, I don't have a very fixed tool name or whatever that I could recommend.
Thank you. What are the other stop words, Smiley?
Yeah. So I don't know if you would be surprised, but one of the other was agile. Not because we were not accepting the principles and the value of agile, but we somehow got bored that people think that if they say that agile, then that's a solution. So agile is not a solution, right? The solution is your work that you need to do. So agile was definitely one that we stopped, at least for a period. And the other one was, which I still find very useful, is that you were not allowed to start a sentence like, the problem is. Okay, so that was absolutely not allowed. You could start with a positive statement, that's all fine, or my personal preference was to say just the challenge is. Okay, so if you just apply this small little change, you will see how the discussion will be different at the end. So that were the two that I remember. Maybe there were some others as well.
Thank you. What do you suggest to change the mindset of the business side to support testing with good examples of user stories when they feel it is irrelevant?
That's a good question. So I think if they think that this is irrelevant, then I would try to figure out what do they feel that is relevant for them. So that so I don't really believe in a kind of approach that you say that user stories are good because there are so many books about that, so that must be good, right? So even though that those books are probably true, but this is not convincing, right? But what I try to do, and unfortunately it's not a good answer for, it's not a pragmatic answer for this question, but you need to do the hard job. You need to figure out what they need, what are their pain points, what kind of things do they want to achieve, and then just keep your mind spinning, and you will probably realize that a good application of these agile concepts like user stories are actually giving an answer for that, and through that maybe you have a better chance to demonstrate the value of this, and maybe you have a better chance to convince them that these things make sense. Not the best answer.
Okay, if you're tired, just give me a blink. With the right eye, because then they cannot see. Okay, that's how cold that you want to leave the stage. Okay.
I don't follow what you say, but I'm not tired. No,
you're not tired. Okay, fine. You're not following. I'm sorry then. Okay. What is your approach to tracking requirements coverage in new and constantly changing environment?
So I think tracking the requirement coverage can be applied in multiple different phases. So there are some teams who are only tracking the requirement coverage during the implementation phase. So they don't care about how the existing features are covered, this is anyway the past, whatever, but at least they want to have a better progress to know how good they are progressing with a new feature. And I think this approach is valuable even if it's constantly changing. I mean, once you have picked at least one for the next 2 weeks, then at least you can see how you are progressing with that particular things for that 2 weeks. And then plan is changing, you have a new assignment, new feature to be done, and you are just planning the progress of that for the modified feature. So it can be applied also as a guiding process, as I said. So it doesn't have to be a metric that you are calculating for every single thing in your project, and you just whatever doing the number crunching every day.
Thank you. Does specification by example work if the specification is very complex?
It works the best if the specification is very complex. For easy specification, you don't need that. The challenge is, and I think specification by example is very good in that, how you can decompose a problem, just take it apart like we did today, and try to find some achievable sub-problems. Okay? Typically, this acceptance criteria, or this rule breakdown that we do, is a good approach to that. You need a little bit of practice. It's not working easily. So, but once you get there, you will realize how powerful it is. Because just imagine that if it's a complex problem, then at the end, there has to be someone who is having an overview of that. Otherwise, let's say if the developer doesn't have an overview of the complex problem, then they will not be able to write a code for that. And usually humans can only take care of 7, 8 factors. So if your complex problem is having more than 8 factors, then there will be no developer who will be able to make a code for that, even if they say that they do. So it's your goal to decompose the problem into smaller ones, which are just focusing on some sub-problems, because otherwise we will anyway not have a quality code. So yes, you need to learn that, and that's basically specification by example. I think it's a good practice to achieve that how to make the complex problem as a composite of multiple smaller problems. That's the key.
Thank you. Tests as single source of truth would mean that we must design test cases during the refinement process of the stories.
So there are multiple test cases. So there are multiple kinds of test cases. So what we were talking about here as in the scope of the specification by example, those are, in spec by example, we call them the key illustrative examples. Okay? Typically, these key illustrative examples should be considered like if there would be a big safety net, right, of tests, but these key illustrative examples just hanging points of that. So we will not be able to discuss all the different variations of data and whatever during a meeting. That would be impossible. We just pick a few key examples, right, describe them, and this description, these key examples, will be the input for the process for the developers. Based on that, they will be able to write the code. And this will be also the input for the testers to be able to fill out the gaps with additional test cases. So yes, those key examples have to be specified during the refinement process, but this is just a subset of all of the tests. Okay, so I don't know if this is answering the question. So that yes, some of them yes, but there will be a lot of testing things to be done even in the later stage.
Perfect. What do we use this coverage percentage for?
That's a question. So that as I said, so in most of the projects where we were doing it, we were using it for tracking the progress and to be able to get an indication whether we are able to keep up the level of quality of our service, of our implementation work that we wanted. So that basically, then you can put it into the definition of done. If the requirement coverage for that particular user story is not 100%, then you are not accepting that particular user story. So basically, it can be used as a gatekeeper or whatever, or a progress measure during the implementation phase. On a bigger scale, so not on the implementation phase part for the existing project, typically, I think people would use that for legacy applications. Obviously, legacy applications doesn't have, they don't necessarily have a full coverage, whatever. They don't necessarily have a very good requirement coverage, but if we are committed to change that, then basically by looking at the requirement coverage numbers over the time, we can see whether we are going into the right direction or not. So that's, again, some sort of track of progress, but in a different way.
I don't know if this is good news or bad news, but the time is up.
There will be a party afterwards, so probably it's
and you're staying?
Absolutely.
Big applause for him. He's going to stay, and he did an amazing presentation. Amazing. And I think this was the longest Q&A, so you were really the hero of the day in my eyes, for sure. But I cannot let you go yet, because you have a little bit of news to announce for tomorrow morning, right?
Yes. So I made a promise or whatever that I would like to try lean coffee as a program point tomorrow in this conference. And how many of you know about lean coffee? A few of you. So basically, lean coffee, because you see the title in the program, but you probably don't know what it is. It's basically a facilitated discussion without some agenda. So in lean coffee, we are putting ourselves into some smaller groups with 8-10 people, and we are just picking some interesting topics, typically about testing, what we are interested in, and we just start to have some discussion on that with some timing. And then once we discussed over one topic, then we take another one and so on. So that's basically the model. It's a very simple facilitation model, but it's very charging, very entertaining, actually, especially for those who are like me, are anyway getting up early. So actually the thing is that the building is actually opening at 8. And there will be coffee from 8:00. That's what I have heard. So if you're feeling that you would like to be participating in that, then just come in early. We are going to start at 8:15, so 8:15, so that you can grab a coffee and just find a team, or we will help you to organize 2 teams. And we will be there where those couches are outside, or we will set up some place for that. And anything else I will explain after that. And we are planning to finish 10 minutes before 9, so you will have time to come into the stage tomorrow, because otherwise people will look angry on me. The one important thing is, because we need to set up the area, it would be good to know how many people are coming. Attila was setting up a button, actually, on this agenda point in the application. What was the name of the button?
I have no idea.
Something like book or something like that.
Book or something.
Book, which is stupid because you don't have to pay for that. But if you are planning to go, and if you would push that book button, whatever, until 6 p.m., then we would have a good indication how many people are going to come, and we can set up the place based on that. So if you are planning to come, then please press that red button.
It's confirmed, it's book.
Okay.
Gáspár Nagy, ladies and gentlemen, this amazing guy finishing off this amazing day. Thank you so much, Gáspár. Have a nice